Before you write a single query, load a single file, or build a single pipeline in Snowflake, there's something foundational you need to understand: how Snowflake organizes everything, the building blocks, how they nest inside each other, and how to design a structure that stays clean and manageable as your platform grows. That's what we're covering in this video. Snowflake has a strict hierarchy, and it determines how you control access, organize data, and scale your environment. At the top is the organization, the umbrella that covers everything. Inside that, you have one or more accounts. Inside each account, databases. Inside each database, schemas. And inside each schema, the actual objects: tables, views, stages, pipes, streams, tasks, and more. The fully qualified name of any object follows this path: database.schema.object name. Most companies start with a single Snowflake account, and most engineers work within that one account day to day. The organization level above it handles billing, account provisioning, and cross-account replication. Larger enterprises sometimes use multiple accounts: separate accounts for production, development, and staging, or separate accounts for different regions to comply with data residency requirements. But the organization level is administrative. The real design work starts inside the account. The most common pattern in well-designed Snowflake environments is organizing databases by data lifecycle stage. A raw database holds data exactly as it arrives from source systems. No transformations, no cleaning. This is your safety net. A staging database holds intermediate transformations, cleaning, deduplication, typecasting. If you're using dbt, this is where your staging models live. An analytics database holds the final, business-ready datasets, what dashboards, reports, and AI models actually consume. Data flows in one direction, raw to staging to analytics. And because databases in Snowflake are purely logical, there's no performance penalty for this separation, only organizational clarity. Within each database, schemas provide the finer-grained organization. Inside RAW, we typically create one schema per source system: Salesforce, Stripe, ERP, so it's always clear where data came from. Inside staging, schemas might mirror the source systems or be organized by domain: customers, orders, finance. Inside analytics, schemas are usually organized by business team: marketing, finance, product, plus a core schema for shared dimensions and facts. Two features worth knowing early: managed access schemas, where only the schema owner can grant permissions. This keeps security centralized. And future grants, which automatically apply access rules to any new object created in the schema, so you don't have to manually grant permissions every time someone creates a new table. Snowflake offers several table types, and choosing the right one for each use case directly affects both cost and data protection. They sit on a spectrum, from maximum protection to minimum cost. Let's walk through each one. Permanent tables are the default. Full protection with up to 90 days of time travel and 7 days of fail-safe. Use them for critical business data you can't afford to lose. But that protection comes with storage cost. Snowflake retains historical versions for the full retention period. Transient tables look the same from the outside. They persist until you drop them. They're visible to other users, but they skip fail-safe entirely and limit time travel to 0 or 1 day. This makes them significantly cheaper for data you can easily recreate. Staging tables, intermediate transformation results, anything you could rebuild from the raw source. Transient tables are the right choice. Temporary tables exist only for your session. When you disconnect, they're gone, completely purged. They're invisible to everyone else, even admins. Perfect for ETL scratch work, temporary calculations, or anything throwaway. External tables are different. They point to data files sitting in your cloud storage without loading them into Snowflake. You can query them like regular tables, but the data stays in your data lake. You save on storage cost, but query performance is slower because the data isn't organized into Snowflake's optimized micropartitions. Use them for large datasets you query infrequently. 3. Newer table types worth knowing. Dynamic tables let you define a query and a freshness target, and Snowflake keeps the results automatically up to date with incremental processing, no manual orchestration. Think of them as declarative pipelines in SQL. Iceberg tables use the open Apache Iceberg format, data stored as Parquet in your cloud storage, readable by Spark, Flink, Trino, not just Snowflake. Important for teams that want interoperability and want to avoid vendor lock-in. And hybrid tables combine row-based and columnar storage, enabling fast single-row lookups and low-latency inserts, transactional workloads, alongside traditional analytics. Each table type solves a different problem. The choice depends on your specific use case. Views are named queries. They don't store data but serve critical roles. Standard views simplify complex logic and provide a stable interface so you can change underlying tables without breaking downstream queries. Secure views add privacy. The definition is hidden, and Snowflake disables certain optimizations to prevent users from reverse engineering underlying data. Only use them when data privacy is genuinely the goal, because the disabled optimizations can slow things down. And materialized views store pre-computed results that Snowflake keeps in sync automatically, powerful for frequent aggregations, but with an ongoing compute cost. We go deep on materialized views in our Snowflake at Scale series. A few more objects that round out the toolkit. Stages are the loading docks, where files sit before being loaded into tables. They can be internal, managed by Snowflake, or external, pointing to your S3 bucket or Azure container. File formats define how Snowflake interprets those files. CSV delimiters, JSON parsing options, Parquet settings. Streams are Snowflake's native change data capture. They track inserts, updates, and deletes on a table since the last time you consumed them, essential for incremental pipelines. Tasks are scheduled jobs that run SQL or stored procedures on a cron schedule or triggered by a stream. They can chain into DAGs for multi-step workflows, and Snowpipe continuously detects and loads new files from a stage into a table automatically. No scheduling required. Naming conventions seem boring, but at scale, they're the difference between a navigable environment and chaos. The standard in Snowflake, uppercase with underscores. Prefix schemas by purpose, raw, stg, dm, rpt. Prefix objects by type when it helps clarity, v for views, pipe for pipes, task for tasks. Use singular nouns for entities, customer, not customers, and document everything with comments. Snowflake supports comment on almost every object type. A short description of what a table contains, where the data comes from, and who owns it costs nothing and saves hours of confusion later. That's the complete picture. Organization, account, database, schema, objects, each level serving a specific organizational purpose. The table types give you control over cost and protection. Views build abstraction layers, streams, tasks, and pipes power your pipelines, and naming conventions keep everything navigable. Design this structure thoughtfully before you start building, and your Snowflake environment will scale cleanly instead of turning into something nobody wants to maintain. This is part of our Snowflake Fundamentals series. Next up, data loading, stages, copy into, and Snowpipe. Follow along if this was useful.